Okay, so this part of Unit 6 is based on proportionality. So let's just go through the notes. This is at the top of page 21. Triangle proportionality theorem basically says that if we have a parallel line to one of the sides of the triangle and it intersects the two sides, which any parallel line would, it's going to divide those into proportional segments. So to formalize this, it's if DE is parallel to AC. So if we have parallel lines, then the split from BD to DA is equal to the split from BE to EC. So it doesn't make equal segments, it just makes proportional segments. And the converse is if we know that we have proportional segments, so if BD divided by DA is equal to BE divided by EC, then we know that there was parallel lines to begin with. So we can do it either way, use either to prove the other. Okay, so let's go through a few examples of this so you can see how this works. In example 1, find the value of x. Well, I see these parallel arrows here, so that tells me that I do have proportionality. So I can say that along either transversal, if I take the two numbers and put them into a fraction, so 12 over 14, I'll get the same thing as if I take the other two numbers and put them into a fraction, so 15 over x. All right, so that's 12x on one diagonal, and it's 210 on the other, and so x would divide out to 17.5. Okay, so same thing applies to number 2. If I take x and 18 and divide those, and I take 56 and 21 and divide those, I have 21x on one diagonal, I have 1008 on the other diagonal, and so x comes out to 48. All right, so that's pretty straightforward, I think, if you just take the parts and you divide them. Now, in exercise 3, there's an extra calculation that needs to be done. So in exercise 3, we have the total distance 55, we have the partial distance 45, so that must mean that there's 10 here. And once you've done that, then you can just go back and set up your ratios again. X over 36 equals 10 over 45. All right, so that would give me 45x, and it would give me 360. So if I divide by 45, I get x equals 8. Okay, same kind of thing here. 27 minus 6 is 21, so fill that in first. 21 over 6 would be one of those sides, and x over 7 is the other. Just make sure that whenever you're writing your fractions, you're coming from the same part of the triangle each time. So I keep using the top part and then the total and then the bottom part just to keep it consistent. So it's 6x equals 147, and x is 24. All right, at this time, pause the video and start working on numbers 5 and 6. Try to get both of those right before we go any further. All right, so for number 5, we should have 30 over x plus 7. And we should have 25 over 15. So I have a cross product here now, so it's 25 times x plus 7, and it's 30 times 15, which is 450. So if I multiply here, I have 25x plus 175 equals 450. And so then if I subtract 175, I have 25x equals 275. Divide by 25 now, and x comes out to 11. All right, so it's no different than the others. You just had a little bit of extra work to do within the multiplication. And we'll set this one up the same kind of way. So I have 21 over 6. And we have, coming from the same part of the triangle as a 21, we have 3x plus 1 over x minus 1. So one diagonal is 6 times 3x plus 1. The other diagonal is 21 times x minus 1. So we distribute. And then we combine terms. So I'm going to get 3x on this side. If I add 21 over to here, I get 27. X equals 9. All right. So hopefully not too many difficulties for you on those. All right. On the next page, page 22, let's take a minute to see how these are set up. So it wants us to determine if MN is parallel to JL. So that kind of goes to that converse where we were saying if we have proportionality, then we have parallel, just like if we have parallel, then we have proportionality. So all we're doing here is testing to see if these two sides divide out the same way. So if I test 11 over 15.4, do I get the same thing as if I test 10 divided by 14? And when I do divide those two, I get the same exact decimal for both. So determine if it's parallel. Yes, MN is parallel to JL. And put segment markings on those two. All right, so all I'm doing is testing the division to see if I get the same answer. All right, number 8, if I take 15 divided by 4, do I get the same thing as 18 divided by 5? And when I divide those, I do not get the same answer, and so there's no parallel lines here. All right, number 9, I need to subtract here first. It's going to be 30, 54 minus 24. So I'm dividing 24 by 30, comparing it to 30 divided by 37.5. And those do come out to the same answer. And so, yes, MN is parallel to JL. Okay, so all we have to do is test that they divide out the same because that's showing proportionality there. All right, next section, parallel lines of proportional parts. So this is basically saying that even if we don't have a triangle, that same parallel line concept applies. So if AB is parallel to CD and parallel to EF, if all those lines are parallel to each other, then all of these parts are going to divide out the same way. So AC divides by CE in the same way as BD divides by DF. All right, so this allows us to divide along parallel lines whether or not they form a triangle. So the same type of equations are going to be written here. If I take the 45 and the 18, they should make the same fraction as 52 and x do. So I just do a cross product, 45x equals 936, and so x divides out to 20.8. All right, can you do number 11 the same way? Just pause for a second and try it. All right, we have 30 over 12. We have x over 14. And just be careful that you are being consistent in the direction that you write your fractions. So if you're going up and to the right this way, you want to continue to go the same way so that we get everything consistent there. So I've got 12x on one diagonal. I have 420 on the other diagonal. Divide by 12, I get x equals 35. All right, just a few more. So number 12, I have 32 and 18, so I want to subtract those first. And then I can go the same direction with my fractions and go x over 27 equals 14 over 18. Now this is a good time to note here that you have in the past used total over parts. When you have parallels like this, we're going to allow you to just take the parts out. That's what this whole parallelism theorem is saying, is that you don't have to do the total anymore. But as soon as you go to a non-parallel part, that's when you have to go back and use that old method. So because these lines are all parallel, these ratios apply. I have 18x equals 27 times 14 is 378. So dividing gives me x equals 21. And over here, 92 is going to subtract 28 and give me 64. So I have 64 over 28 equals x over 31.5. So 28x is equal to 2016. So x divides out to 72 in this one. All right, try the last two. You can pause for a minute, try the last two, and then come back to see how you did. All right, so for number 14, if I take 24 and 18 and make a fraction, take 3x plus 1 and 12 and make a fraction. My cross products have 18 times the quantity 3x plus 1. That'll need to be distributed. 24 times 12 gives me 288. Okay, so then if I multiply 18 times 3x, I get 54x plus 18 equals 288. And subtract 18 over, I get 54x equals 270. And then I need to divide. Make sure I did that right here. So 270 divided by 54 gives me 5. So x equals 5. Okay, and then the last one. See if you set this one up right too. You should have had 2x plus 2 over 21 equals x plus 3 over 12. And for all of these problems on this entire page, you could have had the reverse. You could have had it these fractions upside down, and it would work out to the same exact answer. So the order that you write them doesn't matter as long as you stay consistent. So 12 times 2x plus 2 equals 21 times x plus 3. So just distribute and solve it. So 24x plus 24 equals 21x plus 63. Subtract the 21, I get 3x. Subtract the 24, and I get 39. And so divide by 3x equals 13. All right, so for all of these problems, what we want to be doing is concentrating on finding the parallel lines. If the parallel lines are there, then we will set up a ratio. And if we're trying to test for parallel lines like we were at the top of this page, all we need to do is try each ratio to see if they equal each other.